Hello class, this is the video for section 2.3 talking about laws of limits or limit laws, simply put. Now this is our objective. These are the following. At the end, you'll be able to evaluate limits of functions using the laws. Okay. There are about 10, 11 laws that we're going to consider. Okay, so we're going to start with the first first five. That suppose that you have a constant. Okay, let me change my color to, you have a constant c. Okay, and then you have the limits of two functions f and g exist at x approaches a certain value a. Then the sum, that if you add them, if you add the limits like that, you can take the limits, and what you do is that you can distribute the limit over and write it as this. So if this, suppose this is what? This is b, okay, and that is c, okay, that's a k. So then this will just be what? B plus what? K, because the k and b are what? Are constants too, okay? So that is how we're gonna put it. So that's the first one. The second one is a difference. See, the same f and g, you can write it. That means find the what? The limits of the individual functions and then subtract them, okay? And then you have a constant multiplying a function, means that the same as what? The constant times the limit of the function. Now, in other words, find the limit and then multiply by the constant, which is in front of it. So if you have something like 2x and you're taking the limits, x approaches to say 2. Okay, you can do something like that. We'll look at some other examples. The fourth law is that it's a product. Okay, the product of two functions, the limit x approaches a of f times g, the same as find the limit of f and find the limit of g and then multiply them. The same for what? The quotient, except that the limit, we have put a restriction, the limit of the denominator is not what? 0. Because if it's 0, then it's what? It's not undefined. Now, these laws, we can call them the following. The first law is what? The sum law, which is the limit of a sum is a sum of the limits. That's how you can say this. The difference, we could say that the limit of difference is the difference of the limits. The constant multiple, that is a c times what? F of x, that's the third one. We say that the limit of a constant times a function is the constant times the limit of the function. Okay. The fourth one is the product. That is the limit of a product is a product of what? The limits. That's how you can say this or how you can word them. The quotient also respectively follows that is a quotient of what? The limits, all right, provided that the numerator is not what? 0, okay? So for instance, if f is as close to a certain what? L, that means the limit, okay? This means the limit x approaching a of f of x is equal to L, and then that of g is also m, that is the limit, okay, x approaching b, so the same a of this function g is equal to m. Then of course, if you want to find a sum, like I explained, is what? You just add the limits, so that will be m, L plus what? M, okay, L plus m for that, okay? So let's look at an example. Here we want to consider this graph. Okay, consider this figure 1. The function f, that's for the red one, and the blue is for the g. Okay, so this is your f, that's your g. Now let's look at the functions along the line with the numbers from -4, this is -3, -2, -1, and that is 2. This is what? 3, like that. So let's see what is happening. Now, for part A, where it says that we should find, this is equal to what? Find the limits, x approaching 2, okay, which is the function of x plus, because this is what? The first law, okay, which is the first law. This is law number what? Number 1. If you apply that, okay. Now, Where is 2? This is 2, okay? Now, if I'm considering the limit as we are approaching, x approaches 2 from the left, okay? It's approaching it from the left. So from the right and then from the what? From the left. If this is 2, what is that value is, okay? This is about 1.5, okay? So if you do that, you want to have what? You have about 1.5 plus what? Plus 5 times. Oh, sorry, I was thinking this is minus. This is not, it's not positive. Yeah, it is minus. So here's -2. Now, as we are approaching x from the right, x approaching -2 from the right, okay, the function is what? Is 1. And also from the left, it's also 1. So this is equal to 1 plus, actually this is what? 5 times that, okay? We had this times 5. So this is equal to what? 5 times the limit x approaching -2 of the function g of x, okay? This is 1 plus 5 times, what is that? Let's look at the g. If you're approaching -2, okay, negative from the right, it is this y value, which is what? -1 here. So this is -1. And if you're approaching it from the -2 from the left, also is also the same, -1. So this is basically -1. Therefore, this is 1 minus 5. So the answer is what? -4. Okay. All right. So again, if you use law number 1, we can write it in the sum of limits. Actually, the law number 1, and then here is law number what? Number 3. I believe it's number 3 of. Okay, that's law number 3. All right. So here I did apply law number 3. Okay. Now the second example using the same graph, that is want to find the product. Okay. Want to find the product of these two. Now, what is the product of this is given by, if I use the law number 4, okay, this is the same as the limits x approaching what? 1 of f of x times the limit x approaches 1 of what? G of x. Okay, now if you look at the limit x approaching 1 of f of x, okay, this is 1. And then f of x from the right and then from the left is what? It's going to be what? 2. So this is equal to 2 times, but this does not exist. Okay, why? Why? Because the limit x approaches 1 from the right of g of x, what is that? If it's approaching from the right of g of x, it's actually what? -1. And then the limit x approaching 1 from the left of the same function g of x is, that is, this one is this part, and that is equal to what? -2. Now, since -1 is not equal to -2, we say that this doesn't exist. Okay, so it means that we cannot use the what? The law number 4. Okay, we can't use it. Use law number 4. Okay, for the desired limit. Okay, so what we do is that we'll consider the word one-sided and see if something meaningful will come up. Okay, so first we want to look at the limits, that is x approaching 1 from the right, okay, of, so you have x approaching 1 from the right of the f of x times g of x. So we're going to write it as the limits x approaching right, 1 from the right of f of x, f of x times the limits x approaching 1 from the right of what? G of x. Okay, now if you consider this from the graph, let's look at the f. This is 1. Okay, approaching from that, we have this is 2. Okay, the 2 times. Now, if we're approaching g of x from the right, it is equal to -1. So this is equal to -2. Then let us also consider x approaching 1 from the left for the same problem. Okay, so x approaching 1 from the left of f of x times g of x, okay, is equal to the limit x approaches what? 1 from the left of the f of x times the limit x approaches what? 1 from the left of the other function, g of x. Okay, so now let's consider this. Now, if I have f of x from the left, approaching 1 from the left, is also 2. Okay, and then for the g of x, it's actually equal to what? From the left is actually equal to -2. So this is -2. So you have 4. 2 times -2 is what? -4. So again, -2 is not equal to what? -4. So therefore, we will say that the limit, okay, this limit, what we have here, does not what? Exist. Okay, so that will be your conclusion. Okay, now let's go to the next example using the same graph. Okay, we want to find the limit x approaches 2 of f of x divided by what? G of x. Well, now you know that if I have something like 2 over 0, this is what? Undefined. Okay, that is what is happening here. If I'm approaching 2 from what? From the x approaches 2 of f of x, okay? X approaches what? 2 from, that is this, that's what, okay? It's going from right and then also left, it's actually about what? 1.5, okay? Actually 1.4. So approximately is 1.4, that's why we got this 1.4 here. And then the g of x approaches 2, it said is what? 0. Let's look at this. This is 2, okay? X approaching 2 from the right, and then from the left is also 0. G, that's the y is 0 there. And that's why we got 0. And so if I have the function, the limit, x approaching what? 2 of f of x over g of x. So we use the quotient rule, all right, which says that this is the limit f of x divided by, that's why x approaches 2, and the limit x approaches 2 of what? G of x. Okay, now you are going to have what? Basically what we have for 1.4 divided by 0. And so it's undefined. We said that this definition is true if the denominator, that is the limit x approaches a of the function, is not equal to 0. And so in this case, we say that this limit we have there, the c, which is the limit x approaching what? 2 of f of x divided by the g of x, does not what? Does not exist. Okay, so that will be our conclusion. All right, we're going to consider other laws. So we have 5 already. There's at least 5 more to go. Okay, law number 6. It says that it's called the power law. That means if I want to find the limit of a function, okay, x approaches a of f of x raised to what? N, the same as what? Find the limit first and then raise it, the answer to that power of n. Okay, that is one law. The second law is actually the law of a constant. So if I take limit of any constant, it's the same as that constant. For example, the limit of what? X approaching 2 of 5 or 4 is equal to 4. It doesn't matter. The limit x approaches any number a of say 6, the answer is 6. So the limit of a constant is always constant. I could also have the limit something like this. Okay, the limit x is approaching any number, can be, let's say, infinity even. And this is what is a constant 2. This is also going to be 2. So the limit of a constant is a constant. And then if you know this function x, It's actually a linear function. So this A is satisfied a linear function. The domain is what? All real numbers, right? The domain is all real numbers. That's the domain. So the domain is all real numbers. Therefore, it is in the domain. So if you X approaches whatever number is the same, I just substitute it directly. In fact, this will bring us to the next law, which is we'll talk about with a direct word substitution in a minute. Okay, so that is 6, 7, and 8 laws. Number 9, again, this is a power function. Okay, f of x is a power function. And then the power function like x squared was the domain of that. Okay, if s is equal to the 4th or whatever, the domain is what? All real numbers. So negative infinity to positive infinity. And so in this case, it's in the domain, so we directly will substitute that. Okay, now all these laws that we talked about also hold for what? Roots. Okay, so that gives us the next two. That if I have taken the limit x approaches a, and I have the nth root of x, it is the same as substitute that inside, provided the a is what? Is positive. Because you cannot have, if I have -2, this is what? Undefined, right? It's undefined. So therefore, we want to restrict that the a must approach what? Something positive, so that what is under the radical sign will be positive. Okay, so in case you don't have just a simple linear function, you have any other function, that law also work. We call it the root law. That's number 11. And that you just have to find the limit of the function and take the nth root of that. Now the question is that it's very important. If n is even, then we assume that this limit under the radical sign is what? Is greater than 0. If it's not greater than 0, then of course you cannot evaluate something like -2, as I've indicated here, or -5, for example. You cannot, it's undefined, or it's not real number. It is a complex number. Okay, so we're going to consider other examples now. Specifically, these laws we're going to put all together, and I'm going to solve about 3 or 4 examples. In fact, I picked these from similar to exercise number 1 on page 102 of your textbook. Okay, so here we are given that the limit as x approaches 2 of the function f is what? 4, of the function g is -2, of the function h is what? 0. Now we want to find the following. Okay, now if it doesn't exist, if you find it doesn't exist, we need to explain why. Okay, so if I have this, then this is the same as what? The limit x approaches what? 2 of what? F of x plus the limit x approaches 2 of what? G of x. Now, according to this is law number what? Law number 1. Okay, law number 1. Now, this is given us because the limit x approaches for the f, it is what? 4, then plus minus what? 2, because g, so this answer is what? It is 2. Okay. Now, the second one, using the power rule or power law, okay, this is equal to, what you do is that you take the limit, you can take the limit inside, x approaches 2 of the g of x, and then we keep that. Now, what is the g of x according to this? Is what? -2. This is what? So this is what? -2 raised to what? 3, and that is what? -8. So as simple as that, using the laws. Now, these laws we want to ask, should I have to? Yes, you must know them. Okay, this is calculus class. The thing is that as you use them, then you will what? You will get familiar with it. Okay, so the next example. Okay, the next example is that. Oh, we just finished that. The next example is this one. Okay, so using the square root, or the root law. This is equal to the square root of the limits x approaches 2 of f of x times h of x. Now, what is under the radical sign is what? Is product. So this is using law number 11, okay? We can write it this way. This is law number 11, okay? Now, we can also, because this is product, we can use the law number 4 to write it as what? The limit x approaches 2 of f of x times the limit x approaches what? 2 of h of x, okay? Now, what is the f of the limit x approaches 2 for the function f? This is what? 4. Now 4 times what? 0. And so this is the square root of 0. So the answer is what? 0. Okay. And then finally, we have the last one, which we can write it as, so here I'm using law number 4, okay? And then law number 4 to evaluate it. Now let's go to the next one. So we're going to write this as what? The limit x goes toward 2. So let's let me erase this. Okay, I'm going to apply the law number 5 right now. Okay, so it is going to be the limit 3 times g of x. Actually, we can get more space there. Okay, we get more space there. Okay, so we're going to write this as what? This is equal to the limit x approaches 2 of what? 3 times the g of x, all divided by the limit x approaches 2 of what? H of x. Now, well, this is equal to 3 times the limit x approaches 2 of g of x, because, and we have the limit x approaches 2 of what? H of x. Okay. Now the numerator is 3 times what? Negative 2, but the denominator is what? 0. So this is what? Undefined. So we say that this does not what? Exist. Okay. All right. So that is the next one, using this, all these laws put together. Now the next one is a direct substitution, which I mentioned before. Okay. Now for direct substitution, okay, if you have for a polynomial or a rational function, or for any trigonometric function, provided it's continuous and it's also the a, the number that the x is approaching to, is in the domain. Okay, so if I want to find the limit of a function f as x approaches a certain a, and if that a is in the domain of the function, then I just directly will substitute and evaluate. Okay, so functions with direct substitution property are called what? Continuous what? At a. In general, we have the following what? Useful fact. That is, if f of x is equal to g of x, and the x and a are not equal, then the limits of these two are equal, provided the limits what exist. Okay, so here we're going to use the direct substitution to do 1 or 2 problems, and then some of them will require a little bit of algebra. Okay, but you will get it. All right, so here's examples. Now, if you remember in section 2.2, okay, we did use our tables, or we use the guess method, right, to find this limit. And we got, the answer was this. The answer was what? 1/4 or 0.25. That's what we got. But I'm going to use algebra to the direct substitution. Now, let us try and see. If I substitute directly, I'm going to have what? 2 minus 2 over what? 4 minus 4, which gives me 0 over 0. This is what? Indeterminate. Indeterminate. So, but I can use algebra to simplify. So, use algebra, simplify. Well, so we're going to do the limit x goes to what? 2. We have x minus 2 over what? X plus 2. Minus 2. So this is equal to the limit x approaches 2 of 1 over x plus what? 2. So now you will see that the 2 is in this, it's not in the domain. 2 is not in the domain of the function. But when you simplify it this way, then it becomes, and therefore we can substitute it directly and have what? 1 over 2 plus 2, which is equal to what? 1/4. Exactly what? The same answer what? As we got before. Okay. Now, this question need to be, if I draw the graph, okay, if I construct, I hope I have, I think I have the graph. No, I don't have it here. Okay. If I have the graph of this, okay, this graph is going to be like this. I think I constructed last time. Okay. You're going to shift it to the left. So there's a vertical asymptote. So it's going to go like this. And then it's going to go like that. Okay. If this is 1 and this is 2, there is a hole here. Okay. So this is the graph of the function f of x that we just constructed, which is the x minus 2 over x squared minus what? Minus 4. Okay. Now, let's look at exercise similar to exercise number 4. Using the same direct substitution. Now, this is a polynomial. They are both what? Polynomials. Okay. So the polynomial, the domain is what? The domain is all real numbers. See, that's the domain. And therefore, -1 is in the domain. So we'll do the what? Direct substitution. So we can use the word direct substitution for this problem. So this is equal to what? The limit, okay, it's going to be the limit x goes to -1 of x raised to 4 minus 3x, and then times the limit x goes to -1 of x squared plus 5x plus what? Plus 3. Now, so direct substitution will give me -1 to the 4th minus 3 times -1, then times, this is what? -1 squared plus 5 times -1, then plus what? Plus 3. So what we have there, this will be what? 1 plus 3, okay? And here you're gonna have 1 minus 5 plus 3. And that will give us what? That will give us, let me write it on this side. This will give us 4, that will be 4, that is what? 4 times -1, which is what? -4. That's my answer. Okay. So that is that's for that problem. Now let's look at the next one. Okay. Now look at the expression here. This expression, u squared plus 3u plus 6. It's a true, negative is true is the domain. This is a polynomial. Suppose this is a function f of u. Okay, that's a polynomial. Again, that's a polynomial. Okay, and the domain is the same. The domain is what? -infinity to what? +infinity. Therefore, I can use the direct substitution. And so this limit is equal to the square root of the limit x goes to u goes to -2 of u squared plus 3u plus what? Plus 6. So that gives us the square root of -2 squared plus 3 times -2, then plus what? 6. So this gives us the square root of what? Will be 4 minus 6 plus what? 6. And that gives us square root of 4. And that is what? That is 2. Okay. So with the direct substitution, we can find the following. Now the next example will require some algebra. Okay, we'll have some algebra there. So you got to be careful. Now, if we do again, if I substitute, you see that if u is what? 0. Sorry, if u is 2, okay, yeah, the denominator is going to be 0, which is undefined. And so what we do here is that we rationalize, okay? Since this is not possible, we can use the direct substitution immediately. We rationalize first. So the question is, let's rationalize. Rationalize this. Rationalize the what? The numerator. Now you notice that it's not always, if you have a radical, don't only rationalize the denominator all the time. Sometimes you rationalize the denominator, so the numerator as well. So if I want to do this will be the limit when u goes to what? 2. To rationalize this, I'm going to multiply the numerator, the denominator by the conjugate, okay? The conjugate. That's, I hope this is coming back to you. The conjugate of the numerator is what? 4u plus 1, then plus what? Plus 3. And so we have 4u plus 1 minus 3, and multiplied by what? Square root of 4u plus 1, then plus 3. All divided by u minus 2 times the same thing that we do, 4u plus 1, then plus what? Plus 3, like that. Okay, now if you simplify the numerator, it's going to be just what? 4u plus 1, because you square this, you square that one, and minus 3 squared, because they have negative opposite signs. And then the denominator is what? U minus 2 will stay the same. That is 4u plus 1, then plus what? 3, like that. Okay, so let's see what happens to the numerator. The numerator will just be what? 4u plus what? 1 minus 9. Okay, and they have u, sorry, we have for u minus 2, then times the square root of the 4u plus 1 and plus what? 3, multiply. Okay, so the numerator becomes 4u plus, minus. I want to make sure I have that. It's going to be u minus what? 8 over u minus 2, then times the square root of 4u plus 1, then plus what? 3. Okay, now you can see that the numerator there, we can pull out 4 and write it as what? U minus 2. And then you have u minus 2 in the bottom times the square root of 4u plus 1 plus what? Plus 3. And so this will cancel out. And then you have what? The limit, you have 4. You got 4 over what? The square root of what? 4u plus 1, then plus what? 3. So now we take the limit of that. Okay, remember, we just rationalize the whole thing. So now let's take the limit. We have the limit of what we just got. So u goes to 2 of what? 4 over the square root of what? 4u plus 1, then plus what? 3. Now you see that now I can use the direct substitution. Okay, to do that. So which will equal to what? 4 over what? The square root of 4 times 4, which is what? 16. Okay, which is what? 16 16 plus 1. Sorry, 2 goes into that. That is what? 8 plus 1. Then plus what? 3. So the answer will be what? 4 over what? Square root of 9. 3 plus 3, which is 4 over what? 6. And that gives me 2 over what? 3. So the answer is what? 2 over what? 3. Now, I know this is takes a longer time, but you got to be patient. You can rationalize sometimes. The radical will appear in the bottom, then you rationalize the denominator. This one is in the numerator, so we rationalize. And to rationalize, you what? You multiply the top and the bottom by the conjugate. Okay. So the next theorem is very, very important. You know, in math, we give a lot of things. We have pi to give, you can eat for free. We have the squeeze method. We have the sandwich. We also give sandwich. Now, the squeeze theorem that we're going to talk about is also called the sandwich. So we can get sandwich for free. And then we have the pinching. Oh, ouch, to pinch now. All right. So this is, all these terminologies are the same. Now, what is happening is that if you have the inequality that a function f is less than or equal to g of x, that is, anytime you find a function value, it is less than that. When a is a near, when this is a near value, except that it's possible not at a, and the limits of both f and g exist. So as x approaches a, then we say that that is going to be true, because if you have the function f, which is less than or equal to what the g of x in value, if you take the limit, it must hold that inequality. Now here comes the squeeze what theorem. Now here is what g of x. It is sandwiched by what? 2 functions, or what we say that it is bounded by 2 functions. Now, if the limit of f is what? L, and the limit of h is also L, you see that they are equal, then it means that the limit of the function g being bounded by the 2 on each side, and they have the same limit, will have that limit as well. So that is why we say that if f, the limit as x approaches a certain value a, is the same as the limit as x approaches the certain value of the function h, and is equal to L, then that's what we have. Now, in a graphically, this is what is happening. Now look at it. And sometimes it's hard to find limit of certain functions because of their nature. And so what we do is that if we take the limit of the function h and then the f, and they are equal, then it means that the limit of this function as x approaches a is equal to what? That value. So we have one example that I want to show. Okay. Now notice that we want to find the limit as x approaches what? 4 of the function f, and f is being sandwiched by 2 functions. So let's call this, I want to call this what? H, and let's call this h of x, and let's call this g of x. Okay, it doesn't matter how you label the functions. Okay, so now let us find the limit. Since we want x approaches 4, right? We want to find the limits x approaches 4 of h, and also find the limits x approaches 4 of the function g. And we'll see that whether they are the same. Okay, so let's evaluate them. X approaches 4 of the function what? 4x minus 9. Okay, it's in the domain, so we use the direct substitution. This is 4 times 4 minus 9, which is equal to 16 minus 9 is what? 7. Now let's look at the g. Okay, so this is also equal to the limits x approaches 4 of g, which is what? X squared minus 4x plus what? Plus 7. Well, this is a polynomial function, it's quadratic, the domain is all real numbers, and therefore we use the direct substitution again, which will give me 4 squared minus 4 times 4 plus what? 7. And that gives me also 7. Now you see, since, okay, the limits x approaches what? 4 of h of x is equal to the limits x approaches 4 of the g of x. The function, the limit as x approaches 4 of the function f being sandwiched by the h and g, in this case, is also equal to what? Is equal to 7. Okay. So, and with that, we come to an end of what? This section. Thank you. And I'll follow up with the other videos. Take care.